Good morning, our students, and welcome to this morning's class. Today, we'll be wrapping up our discussions this morning on interval estimation. For some times now, we have been talking on estimation, types of estimations as it concerns the point and interval estimation. Under interval estimation, we have discussed a lot, ranging from interval estimation for one population mean, interval estimation for the difference of two population means. Today, this morning, we want to discuss interval estimation for population proportion and then discuss it under two categories, one for one population proportion and then for two population proportions. Under the two population proportions, our interest will be to estimate or to construct interval for the difference between two population proportions. However, before we go into the discussions in detail, it is important that we make our class to understand clearly what is meant by proportion here. Consider, for instance, a population, which of course is made up of a group of persons. And this group of persons exhibits a binary characteristics. Binary characteristics in the sense that the group can be partitioned into two. Say, from this group of students, from this group of people, some can be students, others might not be students. So when a particular individual is selected from that group, that individual can either be a student or he or she cannot be a student. So the interest here is, what is the ratio of those who are students from among this group? That ratio is, of course, what we refer to here as the proportion, which we can say the proportion of students from that group. It can equally be classifying a given population into two, such that any particular person selected from that population can either be a student, can either be a worker or you are not a worker. Interest equally here could be obtaining the proportion of those who are worker from that population. That is what we refer to as proportion. And then, of course, conventionally, the population proportion is always denoted with, permit me to write what we have. We are looking at what we call interval estimation. Interval estimation for population proportion. For population proportion. Okay? I was about to say that the population proportion conventionally is denoted with pi, written as this way, is written as what? Pi. So you can be talking about the proportion of students from that population. You might be talking about the proportion of those who are workers in that population. Most of the time, this pi, the value of this pi might not be what we know. And then the interest becomes on how we can estimate the value of this population proportion. And because of that, we go ahead taking sample from the population of interest with which to estimate the value of this population proportion. And when we take a sample, from population of interest, taking a sample from population of interest, then we are going to represent the ratio of those in the sample that exhibit that particular characteristics of either being students or being a worker from that sample with P. We are denoting it with what? With a letter what? P. Where this P will be defined as what? X all over what? N. X here stands for the number of those in our sample that are students, all over the total number of the people in the what? In the sample. Or X here can stand as the number of those from our sample who are what? Workers, all over the total number of the persons what? In the sample. So this P now here stands for the sample estimate of the population proportion pi. However, our interest here is to estimate interval that we know is going to contain this unknown population proportion pi. And this, of course, this interval, like we have always been saying, can be represented with what? L and what? And U. This L is what we call the lower confidence limit, and then this U is what we call the upper confidence what? Limit. So that our interest is having this lower and upper confidence limits estimated from the sample in such a way that it is going to contain the unknown population proportion. So what we now are going to have becomes that we are having what? That L is less than or equals to what? Pi, which is less than or equals to what? U. However, like we have always been saying, defining L and U is not enough. Our interest is getting a value of what? Of L and U that will contain the unknown population proportion with a given level of what? Of confidence, or a given level of what? Of probability that these are L and U are going to contain the unknown population proportion pi. So in that case, what we are now going to have is what? P is L less than or equals to what? Pi less than or equals to what? U, which will be given as 1 minus what? Alpha. This 1 minus alpha, like we have been saying, is what we call the confidence level. And then this alpha is what we call the level of what? Of significance, which in this context is the probability that our confidence what? Interval L and U fails to contain the unknown population parameter pi. And then that's the reason, of course, this pi or this alpha is always kept as small as possible. And then if you say that small value minus from 1, you still have a very high probability that this L and U are going to contain the unknown population parameter pi. So as a way of recap for the much we have been saying, once we want to talk about what? Proportion, definitely you should be talking about what? A population that exhibits what? Binary characteristics. That's any unit from that population can either belong to this group, but you can never belong to the other group. There are categorically two groups. You either belong to this group or do not belong to this group. When you are talking about population of what? People, and your interest is classifying this population now in terms of whether you are a student or you are not a student. At the same time, no particular individual in that population will be a student and equally will not be a student. So you are either a student or you are not a student. If you are classifying based on what? On workers, you can either be a worker or you cannot be a worker from that particular population. So the interest becomes, how do we now estimate the population proportion when it is not what? Given, or when it is what? Unknown. Of course, most of the time now, we cannot know the population proportion, and then trying to estimate it now from the entire population is not going to be possible, because most of the time, the entire unit of the population cannot always be reached. So we resort to taking sample. And then from that sample now, we are now going to estimate the population proportion. And we say that the moment we take, the pi stands for the population proportion, but the moment we take a sample and from that sample we want to obtain the value of the population, of the proportion, we are going to represent it with what P. And that P is going to be defined as X over what over N. Where this X now will stand for the unit in our sample that exhibit a particular characteristics. Perhaps who are students or perhaps who are workers. All over the total number of the people now included in what in our sample. But we are saying that our interest here is to obtain an interval L and U that is going to contain this unknown population parameter theta. That is, rather than estimating a particular point estimate to represent this unknown population parameter, we decide now to estimate L and U that will bound the unknown population parameter pi. And then we say this L and U are, of course, what we call the lower confidence limits and the upper confidence limit. And then this one now is the probability that our confidence limits L and U are going to contain the unknown population parameter pi with this level of confidence. So this is the little introduction I want to give about proportion. So we are going to clean the board now and talk about estimating the confidence interval for one population proportion. One population proportion. So permit me to clean here. Interval estimation for one population proportion. Interval estimation for one population proportion. Okay? Our interest is on one population proportion. So therefore, that population is going to have unknown population proportion pi. Okay? Unknown population proportion pi. Okay. Now, because we want to estimate the unknown population proportion pi, we are going to take one sample from this one population. And then let that our sample be, we have what we call x1, x what 2, down to what to x what n. From this, our sample ranging from x1 observations to xn observations, we are going to estimate the sample proportion. And that sample proportion, of course, like I earlier had said, is given as what? As P is defined as what? X all over what? N. Where, of course, X and N stand as earlier had explained. So our interest, as usual, is going to be on L less than or equals what? U less than or equals what? Less than or equals what? Pi less than or equals what? U. Which, of course, is going to be P of L less than or equals what? Pi less than or equals what? U at what? 1 minus what? Alpha. So the question is, how do we now get the true value of this our L and U? Okay? That will satisfy this condition or that will contain this unknown population parameter pi, satisfying this condition under this condition of one population proportion. Okay? For us to have the true value of L and U that will satisfy these conditions mentioned, L and U will be defined as L, U will be given as, we have what? P, okay. Then plus minus z of alpha over what? 2, then square root of what? P into 1 minus what? P all over what? P. And like we have always said, this our z of alpha over 2 is what we call the critical value of the confidence limit, which is of course read from the standard and normal distribution. And these are P, 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 and P, of course, is the sample proportion, which of course from whatever sample you are taking now, you'll be able to estimate your P. And then once you now fix them into this, evaluate this expression with respect to what to plus, you are obtaining what U. When you evaluate it with respect to what to minus, you are obtaining the value for what for L, which is the lower confidence what limit. So the moment you know the true value of this P, you substitute them into this. This value of the critical value must have been read from what? From a standard normal distribution table if it is not what given. At the end, you evaluate this expression by saying whatever thing you get here minus this P. By that, you have obtained your what? Your L. At the end, you say whatever thing you evaluate from this plus P. By that, you have obtained your what? Your U. And that your L and U will definitely contain the unknown population parameter pi with 1 minus alpha level of confidence. So that's just what we do under one sample confidence interval for one population proportion. So before we take question on this, let us quickly clean the board and talk about interval estimation for two population proportions very fast. So we are talking about what? Two population proportions. So here is one before. I will now change it to two. Will now change it to two and then put proportions. This time around, we no longer have one population, we have two populations, which of course we can say, let us have denote them as population 1 and then population what? 2. So we have POP1, POP1, and then we have what? POP2, POP2. This my POP1 is standing for population 1, this one is standing for population what? 2. And we should pay attention here that in population 1 can be classified into two. That is into a binary what? That is population 1 is exhibiting a binary characteristics. You can come to population 1 now and then you classify them, those who are students and those who are not students. And then the ratio of those who are students to the entire what? Population now is what we refer to as what? As a pi. That is the ratio of those who are students in that population. And of course, because we have a population y, we are now going to represent that as what we call pi 1. The ratio of those who are students from population 1, pi 1. The same thing applies here now. Ratio of those who are students from population 2 is going to be given as what? Pi 2. Okay? Because we don't know the true value of this and we don't know the true value of this, definitely we are going to take what we call sample. We are going to take sample. And then when we take sample now, we are going to have what we call the x11, then the x12, down to our x1 and 1. And then here we are going to have equally x21, x22, then down to what we call x2 and 2. What we just mean by this is, as what we have been saying, the first observation from the first population or from population 1, second observation from what? Population 1, up to nth observation from population what? 1. Putting this n here is to help us make distinction when we should be working with the sample size. So whenever we see n1, we now know we are talking about what? Sample size of population 1. Sample size of sample 1. The sample size of the sample taken from population what? 1. So when we come here now, these are first observation from population from sample 2, second observation from what? Sample what? 2, down to the what? To nth observation from the population what? 2. Okay? So these observations were taken from population 1. These observations were taken from what? Population what? 2. So it is from this sample here, or observations here, that we are now going to estimate what we call the sample proportion. And then we are going to have what P1 here now is going to be given as what X all over what N1. So what you mean here is the sample of, or what we call the proportion of those that exhibit that characteristics from the sample taken from population what 1. That's why I'm representing it with what with P1. So here equally, I am going to have what we call P what 2 is given as what X all over what N what 2. This my N1 here is talking about the sample size taken from the population 1. This one is the sample size taken from population what 2. And our interest is to get the estimation of interval for the difference. Please permit me to put for the difference. For the difference of two population proportion. Because our interest is to obtain the interval that is going to contain the difference of pi 1 minus what? Pi 2. That is our interest. So in that case now, what we are now talking about is what? We are talking about L is less than or equals to what? Pi 1 minus what? Pi what 2, which is less than or equals to what? U. So and then we are now be saying P of L less than or equals to what? Pi 1 minus pi what? 2 less than or equals to what? U. At 1 minus what? Alpha. So how do we obtain the true value of L and U? That are going to bound the difference between the two population what proportions at this level of what of confidence. That is what this particular thing is saying. Or that the probability that the confidence limits L and U are going to contain the difference between the two population proportion is given as 1 minus alpha. Okay? So what is the true value of L and U that will satisfy this condition? The true value of L and U that is going to satisfy that condition is given as, open a bracket is L and then U. This is given as, you open a bracket, this is P1 minus P what 2, close the bracket. Then plus minus, general square roots. So you have what? P1 into 1 minus P1 all over what? N1 plus P what 2 into 1 minus P what 2, close the bracket, all over what? N what 2. So with this formula, permit me to put the Z, which I forgot here, Z of alpha over 2. Permit me to put it there. So this is equals, open a bracket, P1 minus what? P what 2, close the bracket. You have what? Plus what? Minus Z of alpha over 2. So you're, of course, we're already familiar with all these things. Because actually, this class we're having is a continuation of the classes that we have been having for the interval estimation or on estimation. So we equally refer you to those classes so that you get abreast with some of these definitions that we are making, because they are springing from somewhere. Okay? So this is the formula we are going to use when we want to estimate for the difference between two population proportions. So permit me to clean the board and then we take some questions from this textbook. Thank you very much. Okay, let me read the first question here, which we have from this textbook. Let me read the first question. The first question says, and I read, he said the Independent National Electoral Commission is interested in finding the proportion of students that are registered voters. Proportion of students that are registered voters. So number one here, the population of interest here is population of what? Of students. So we have population of students. We have population of the students. population which is equals to what? Students. Okay? From this population, which are of course students, this population can be classified what? Into two. You are either a registered voter from the population, or you are not a registered what? Voter. So you have what we call registered voter, registered voter, or you are not registered voter, not registered voter, not registered voter. Okay? That is why I earlier had said that that population must have to exhibit binary characteristics. Okay? I repeat, the Independent National Electoral Commission is interested in finding the proportion of students that are registered voter. In a random sample of 200 students. So in order to do that, they went ahead and took sample from this population of students. And that random sample is sample of 2,000 students. So our n equals 2,000. They took, just like you're having what? X1, comma what? Comma x what? 2, comma, down to x of 2,000. That's what that thing means. So our n here is equals to what? 2,000. 2,000 what? Students. So in a random sample of 2,000 students, 745 are registered voters. 745 are registered voters. So from this sample of 2,000 taken, 745 registered voters. Registered voters equals 745. Okay? They say establish 95% confidence interval for the population proportion of students that are registered voters. Establish 95% confidence interval. 95% confidence what? Interval. Yes. For the population proportion of those students who are registered voters. So we begin this way. So as a way of solution, permit me to have a line here. Okay. Our interest is to go ahead and obtain the value of what? P. That is our interest. So as a way of solution here, we say solution. Okay. The interval is going to be, of course, our L, and U is going to be P plus minus Z of alpha over 2 square root of what? P into 1 minus what? P all over N. Why are we using this formula? Because of course we have only one population that they took. They took a random sample. They took only one sample. They took a random sample of 2,000 from this population of what? Of students. So one population of what? Student. One sample containing 2,000 observation. So the interest is on estimating intervals for one population proportion, which is the proportion of those who are registered voters from the population of students. Okay? Then we go ahead. We now say but our P is given as what? X all over what? N. Of course, you remember that we said that X are those that exhibit characteristics of interest, which could be when we are classifying earlier whether you're a student or you're not a student. So our X was you are a student all over the total number of what? Students. All over the total number of people in the sample. But the interest here is whether you are a registered voter or you are not a registered voter. So this X here stands for registered voter. While this our N here now stands for the total number of what? Units or persons in the sample. The total number of people in the sample is 2,000. But from these 2,000, those who are registered what? Voters are what? Are 745. So X is 745 and N is 2,000. So this thing becomes that this equals what? 745 all over 2,000. And then if you pick a calculator and do that, what they give that it is here is 0.37. They say that this equals 0.3 what? 725. So you can cross check to see whether what they have there is right. Okay? And they gave us a hint. The hint that they gave us earlier is that they told us that Z, that is a hint, that Z of 0.025 equals what? 1.96. That is the hint that they gave us. We can actually read this thing from a standard normal table, but because it's going to take a lot of our time showing the standard normal table, and then it might not be visible enough for us to see or for our students to want to see. So what we are now going to do is that we return back here. The confidence interval they gave us is what? Is 95% confidence interval. So from this 95, we can actually get the value of our what? Of our alpha. Because we know that we can get the value of alpha. This 0.95 can be written as we have 100 into 1 minus alpha in percent is given as 95%. This percent and this percent will go. We open this bracket. 100 times 1 will give me 100. 100 times alpha will give me 100 what? Alpha. This equals 90 what? 5. So that minus 100 alpha is equals 95 minus what? 100. And minus 100 alpha should give me what? Minus what? 5. So that this minus and this minus can cancel. Then we can say all over 100, all over 100. This 100 will cancel this 100, and alpha is going to give me 0.05. And if you watch this RZ here, this RZ here, of course, is alpha, Z of alpha over 2. So I will now say, therefore, this equals, my P is already this quantity. So I have 0.3725. Here is what? Plus what? Minus. We have our Z, alpha is already 0.05. When you divide 0.05 by 2, you arrive at 0.025. So I have Z of 0.025, then square root of. Here is already this quantity. So I have 0.3725, open a bracket, 1 minus 0.3725, close the bracket, all over 2,000. Because my n is what? Is 2,000. And of course, without wasting much of your time, we have been given that this value is 1.96. So you can just remove this and replace with 1.96. And the moment you replace with 1.96, you evaluate this whole expression with respect to minus. When you do that, you are getting this L. How do we mean by this? Just use this 1.96 and multiply the square root of this square root here. When you have done that, you say this quantity you have here minus whatever thing you got here. That has given you L. At the end, you return back. Whatever thing you get in this evaluation plus this quantity you have here, you are getting what? L. And from what they have in this textbook, when you do the subtraction, what you have is this. You have therefore, L of u is given as. When they did subtraction, the value they had was they had 0.3513, and then what they had when they did the addition is 0.3937. So this of course becomes the confidence interval that will be able to contain the unknown population proportion of students who are registered voters. Okay, so this is what we have that is going to contain them. They contain it. They are the value of L and U. Thank you very much. There's nothing too difficult here that we cannot on our own understand. But we have always pleaded with you. If you're having challenges, that's the essence of the comment section. Register your concern in the comment section. Once we come across it, surely we'll try to provide solution to that. Please permit me to clean the board so that we can take the second question. Okay, the second question says, and I read, I'm going to be calm reading it so that we can have a deeper understanding of the question. That question says, two random samples. Earlier on, what we saw was a random sample. Here they are saying two randoms. Permit me to bring down my curtain. The reflection of light is coming from my window. Okay, sorry for that distraction. Two random samples are taken, one of male voters and then the other of female voters. So two random samples. One male voters, two female voters. So I have two random sample. Then that sample is male voters. Male voters. The other one is female voters. Female voters. Okay? The male voters they took is N1 equals 150 male voters. And then the other one is N2 equals 130 female voters. Then we go ahead. It is found that 75 men in the first sample are in favor of candidate A. So these male voters can be partitioned into two. Those who are in favor of candidate A and those who are not in favor of candidate A. So this male voter is looked at as a population that can be classified into two. Those who are supporting candidate A and those who are not supporting candidate A. So, and we are told that 75 men are interested in candidate A. Are we there? So we are now going to say that for candidate A, we have 75 men. For candidate A, A, 75 men are interested in him or have preference over him or for him. Then, and 60 women in the second sample are in favor of the same candidate. So when we come here, we have also candidate A, this time around 60 women. 60 women. Okay? What is the confidence limit for the true difference in the voting preferences between men and women, given that 1 minus alpha equals 0.95? It says given that alpha, so given that alpha, given that 1 minus what alpha equals 0.95. we are going to pay attention here. This thing boils down to what we call interval estimation for the difference of two population proportions. Reason: we are going to estimate the proportion of those who prefer candidate A from male voters, estimate the proportion of those who prefer candidate A from female voters. And of course, you know that the population proportion of the male voters who prefer candidate A is given as what we call pi 1. And the population of women, of course, the proportion of women who prefer candidate what A from female voters is going to be given as what pi 2. Okay. But they have gone ahead and taken a sample, and the sample they took is what? 150 from male voters. So I want to calculate the proportion of male voters who prefer candidate A. 75 men prefer candidate A out of 150 people taken in the sample. So I will be able to have that my P what 1 is given as what we normally write as X all over N1, which of course our X is those who prefer candidate A, 75 all over the total number of people in the sample, 150. So I will equally come here and be able to obtain the proportion of those who prefer candidate words A in the sample taken from the female voters. So here I will have what we call our P word 2 will be given as X all over N word 2, which of course is 60 all over 130. That's what we have there. Okay? So with this in mind, our interest still remains on the difference of pi 1 minus pi 2, where this pi 1 is proportion of male voters preferring candidate A, and pi 2 is proportion of female voters preferring candidate what A. So we are talking about our L less than or equals pi 1 minus pi what 2 less than or equals what U, which implies that we are talking about probability that L is less than or equals to pi 1 minus pi what 2 less than or equals to what U is given as 1 minus what alpha. And of course, we are now saying what is going to be the true value of L and U that will satisfy this condition. And remember, that was what we discussed earlier, that the true value of L and U is going to be, we have that L, U will be given as, open a bracket, we have what? P1 minus P2, close the bracket. Then we have plus minus Z of alpha over 2 square root of what we call P1 into 1 minus P1 all over what? N1 plus you have what we call P word 2 into 1 minus P word 2 all over what? N word 2. And good enough, we already know all these things. Why we already know all these things is that we know quite alright that our P1 is here, our P2 is here. So there is nothing, and now of course Z of alpha over 2, we are told that 1 minus alpha equals to 0.95. And for that reason, of course, this alpha is going to be 0.05. Because if you take this one over there, you have minus 0.05. So you cancel the minus and minus, you have that alpha is equal to 0.05. And if you bring 0.05 here, divided by 2, definitely you still arrive at that our 1.96, which we earlier had said that they gave us that time, 1.96. Okay? So in that case, what we are going to do here becomes that this equals, we now open a bracket here. Our pi 1 is this, so we have, our P1 is 75 all over 150 minus. Our P2 is 60 over 130, 60 over 130. You close the bracket, plus minus. This Z of half over 2 is just like Z of 0.05 over 2 which is z of 0.025, which is 1.96 that they told us in the first question. So at 1.196, we have general square root. Then here we have our P1 to be 75 over 150, 75 all over 150. We open a bracket. Here is 1 minus 75 all over 150, close the bracket, all over. Our N1 is 150. We have 150, then plus. This one is 60 over 130. We have 60 all over 130. Open a bracket, 1 minus 60 all over 130. Close the bracket, all over. The total units in the sample is 130. Okay. So with this, of course, you evaluate this thing with respect to when it is what minus in order to get L, and evaluate this with respect to what to plus in order to get U. And with that, you must have gotten the value of L and U that will be able to contain the difference between the difference of the population proportions of voters, of male voters and female voters that prefer candidate what A. And if you try to evaluate this, you can cross-check what you are going to get from what they gave in this test book. Because what they gave in this textbook is this, that they gave this. So permit me to clean here and use it to give you what they got. What they got is this. They had this. They had a minus 0.07921, comma 0.15521. This is the value which they got. So you can actually try to evaluate this and know whether you arrive at exactly what they have here. Thank you very much. Let us save the length of this video so that you don't find it boring. This is the much that we will be taking on interval estimation for the population proportion for now. Stay tuned for our next classes that will be coming to you on different topics in mathematics and statistics. We encourage our students that a situation whereby you see our videos or you get notification of our videos, you just need to look at the video and then know whether it's something that concerns you and concerns the outline of your courses, and then be able to go through it and raise questions when you wish to ask. Do not forget to subscribe to our YouTube videos, and do not forget to equally like, share with your friends, and then you definitely learn and gain a lot from this. So thank you very much.